One, two, three.
What's up, team? Today we're going to talk about solving quadratics by graphing. Learning target, I can solve a quadratic by graphing. So I got some step-by-step, we're going to walk through it, but let's start over here with our example. It says solve for x, and we're given this equation, x squared equals 6x minus 5. This looks like a doozy. This looks a little unlike things that we've seen in the past. We have x's on both sides, we have an x squared. This looks like it could get weird. But I'm going to show you how to solve this by graphing, not necessarily doing any like gnarly algebra. So step one, we're going to gather all three terms on one side. So what that looks like is right now we have terms on both sides. We want everything on one side, and so it's going to be like stuff plus stuff plus stuff equals 0. That's our move here. So to do that, I'm just going to subtract 6x from both sides. And the result of that move, we have x squared minus 6 equals, well, this negative 5 is still over here on the right. Cool. So now I still have things on both sides, so let's do this once again. Right now, this negative 5 is kind of camping by itself, so we're going to add 5 to both sides. Add 5 to the left, add 5 to the right, and the result of this move is x squared minus 6, oh, that should be 6x, my mistake, minus 6x plus 5 equals 0. This is the algebra that we're going to do. So x squared minus 6x plus 5 equals 0. We've seen things like this before, x squared minus 6x plus 5. The difference is the way that we've seen it is we've seen f of x equals x squared minus 6x plus 5. And we know how to graph stuff like this. We could use the vertex formula, negative b over 2a, find our 5 essential points, plot the points, connect the dots, and draw arrows at the end. So I'm not going to walk through how to graph it. There's other videos for that. You've seen it before. I am going to graph this on Desmos, and we're going to kind of make some observations about it. So that's our step 2. Graph the quadratic. So check this out. I'm going to open up Desmos now. Desmos.com/calculator, and over here on the left-hand side, I'm going to type in our quadratic. So instead of f of x, I'm going to type in y because that's how Desmos recognizes it. So it's x squared minus 6x, and then we have a plus 5. Boom. Okay, so we have all of the pieces here. Here's what our quadratic looks like. It goes up forever. It looks like we have a vertex down here at 3, negative 4. There's another point right here. Is at 4, negative 3, if I can get it just right. I'm not able to capture. There it is, 4, negative 3. Boom. Okay, now what we've done with ours, I'm going to pop back to myself real quick. We'll come back to the graph in a moment. What we have done for our quadratic is we solved it for 0, and then I did this like crazy move where I was like, hey, forget the 0, let's turn it into an f of x. So really what we've done is we took this graph and we examined it for all x values. And that's cool. It gives us really an infinite amount of information, but really all we care about for this particular equation is, well, when does f of x equal 0? Because that's the substitution that we did here. We had 0 equals stuff, and we turned it into f of x equals stuff. So we substituted this term f of x in for 0, essentially is what we've done. So to solve this equation, all we need to do is look at our graph and figure out where the heck does f of x equal 0. Well, remember, f of x is kind of a replacement or synonymous with our y. So this is going to be wherever y equals 0 on the graph. And where does y equal 0? I'm pretty sure that's just everywhere on the x-axis. So let's look at our graph again. And we have our x-axis. That's the one that goes side to side. The y-axis, of course, is the one that goes up and down. So where does this graph touch the x-axis? Well, right here at 1, 0, and right here at 5, 0. So where are the solutions to this? The solutions to this are when x equals 1 and when x equals 5. So we would say the solution to solve for x, well, our solution, x equals 1, x equals 5. And that is actually it. We're done. We've solved this thing. Okay, if you're somebody who's unconvinced by that fact, I'm right there with you. This seems weird. This seems like a little math magic. So let's verify. All we need to do is take our x equals 1, plug it in for x, and see if it's true. If it's true, then it's true. We'll do the same thing with 5. So right here we have x squared equals 6x minus 5, back to what we started with. I'm going to replace the x's with 1s, and then I'll do the whole thing again with 5s. So this is 1 squared equals 6 times 1 minus 5. And I'm going to put a little question mark here. Is it true? I don't know. Let's find out. 1 squared, that's 1. 6 times 1 is 6 minus 5. Oh, this checks out. 1 equals 1. Cool. So at least it's true that x equals 1. Let's check the x equals 5. So it's going to be 5 squared. Separate these out here. 5 squared equals 6 times 5 minus 5. This looks good. And again, question mark. So we have 25 equals 6 times 5. That's 30 minus 5. 25 equals 25. That is a true statement. If you were to plug any other number in here for x, you would not get true statements. We found the only 2 solutions of this quadratic. Because of the nature of quadratics, looking back at our picture here, or our graph, because they are in parabola form, more often than not, when you solve a quadratic, it's going to have 2 solutions. And I think that's easy to see once we look at the graph, because it kind of mirrors itself. It's got this axis of symmetry. So generally speaking, when you solve a quadratic, it's either going to have 2 solutions, because like here, it touches the x-axis twice, or let's say if we were looking at something different, instead of this plus 5, say it was like a plus 15 or something, and then the vertex is moved up and this thing goes up and up and up forever, it's going to have 0 solutions because it's never going to touch the x-axis. Once in a while, you run into something. Let's see if I can find it just right here. Let's see. Boom. I don't actually. There it is. Here we go. If this c value was a 9, we could see that the vertex is right here on the x-axis. This is a rare case where there's only a single solution. For this particular quadratic, there is a solution of x equals 3, and there's no more correct solutions. Okay, this has been an example of how to solve quadratics by graphing, again, step by step. Gather everything on one side. You should have stuff equals 0. Then you're going to substitute f of x in for that 0, graph. You can graph on Dismus for the time being. That's great. You already know how to graph it by hand. We spent a whole unit on that. So that's step 2 is the graph. Step 3, just look at the graph. See where the parabola crosses the x-axis, and that is your solution. Sometimes there's no solutions. Generally, there's 2 solutions, and sometimes there's only 1. All right, let's dive into this practice problems. You got this.